Example 5, we're going to be doing mixed operations. So what that means is every single one of these problems is going to be different. And our goal is to simplify completely. We have multiplication here, and it's multiplying 3 different binomials. So just thinking back, if I were to multiply numbers, I would first start by multiplying the first 2 and getting the number 6. Then take that answer, 6, and multiply it times 4 and get 24. We're going to do the same thing here. Whenever I have parentheses touching, I should have probably mentioned that earlier, but here I am now. Whenever I have parentheses touching like that, that indicates multiplication. There does not have to be a dot in between it. It's just understood to be multiply. So I'm going to multiply these first 2 parentheses together using a double distribute. So m times m is m to the second. M times negative 2 is negative 2m. 2 times m is positive 2m. And then a positive 2 times a negative 2 is negative 4. Now I'm going to put that in parentheses. And then I still have to multiply times m minus 3. I can combine some like terms here. Negative 2m and 2m is 0, so that's gone. And then I'm left with m squared minus 4. And notice I put that in parentheses when I multiply that. And then I have left to multiply it times m minus 3. So now I'll double distribute again. So I have m to the second times m, which is m to the third. Then m to the second times a negative 3, which is a negative 3 m to the second. Negative 4 times m, so that's negative 4m. And then negative 4 times negative 3 is plus 12. So I'm going to look to see if I have any like terms, and I don't. So there's my final answer. All right, so compare the looks of this where these are touching and I did multiplication to example C where I have a subtraction in between it. So that means that I'm going to take the first parentheses and I'm going to subtract the second. So recall that subtraction, when we first learned it, is the same thing as addition of the opposite. So when we do this, 3x plus 2, I'm just going to write that. It's really understood to be distributed 1 there, so that's just 3x plus 2. There's nothing to do to it. And then this minus is really technically going to be a plus a negative 1 times 5x plus 7. So that's going to give me 3x plus 2. And then I'm going to have a negative 1 times 5x. That's a minus 5x. And a negative 1 times 7 is negative 7. So kind of look at what happens. When I have subtraction, it's going to be subtract the 5x and subtract a 7. And that's the way that looks, kind of skipping over that middle step right there. All right, so once I finish my subtraction, I'm going to combine like terms. So I have negative 2x. Then I have a positive 2 and a negative 7, which is negative 5. And that's my answer for that. All right, so let's look at D next. Let's take a look at this and notice, I mean, it just has that feel of having a parentheses where you might double distribute, but there's not. There is not a parentheses. You might be tempted, right, to do, there's some subtraction. 7y minus 5y would be 2y, but that's not right. Why? Because we need to use PEMDAS, and PEMDAS is going to say to do my multiplication first. So here I have subtraction, and here, because this y is touching the parentheses, I have multiplication. So I need to do my multiplying before I do my subtracting. So we're going to then, I'm going to do a plus, a minus, and I'm going to be thinking that as a negative 5y distributing through. So I have 7y that's just going to stay there. And then I have negative 5y times y as a minus 5y to the second. And a negative 5y times a negative 2 is going to be positive 10y. Then once I finish that, I want to put it in descending order. All the others have been kind of naturally there, but I want to put it in descending order, so I'm going to put my minus 5y to the second in the first left spot. And then I have the 7y plus 10y, which is plus 17y. And we'll finish up these B and, does that look like an A down there? We'll call this an E next class.